Okay, so we're ready. Out of 2.7 here, we're just only going to do one of the concepts that are contained in that particular item. Now, here's some notation for you. This is something new. Before, we've only had f of x or g of x, like these. This notation says that we're going to take whatever equation that f of x is and whatever equation g of x is, and we're going to add those two equations together. Likewise, this one says that we're going to subtract whatever the g of x equation is from the f of x. This is kind of like when we had the minus in the middle problems back in chapter 1. You got to watch your signs on this. The order matters on the subtraction one. The order does not really matter, although you should do it in the correct order on the plus side of this. Multiplication, we're going to take the two equations and we're going to multiply them together. That might involve distribution. It might involve foiling. The order doesn't matter, but it's better if you keep it in this order. Now, for division, we're going to divide the first by the second. Now, there are two constraints on this. The order matters on this one. And this one can't be equal to 0 because then you would have an undefined value. Okay, let's look at this example. Now, in this example, okay, we're just doing a substitution. We're replacing the x with negative x. So, if we're doing this with equation f only, then we replace the x with -3, this x with -3, and then we simplify. They didn't show the simplification. -3 squared is 9. Negative, negative is positive, plus 9 more is 18, plus 1 gives you a value of 19. Okay, if we have equation g of 4, we replace this x with a 4. 8 minus 4 is 4, and the square root of 4 is 2. In this case, we're back to the f equation. We're replacing it with a plus 1. So we replace each x in the equation. We have to FOIL this, getting a squared plus 2a plus 1. We have to distribute that, getting -3a minus 3, and bring down the 1. We combine like terms, and we get the answer of a squared minus a minus 1. Okay, if g of x is 10, or g of 10, so we have, in this case, 8 minus 10, which is a -2, so that one is undefined. Or we could have an answer of 2 square root of 2i, easy for me to say. Okay, here are our same three functions again that we had before. This time it wants us to subtract these with a replacement value of -8. Now, you can go through and do the algebra on this and then substitute -8, but it's far easier to do the substitution separately and then do the subtraction. So in other words, we're going to do the substitution separately. So we take the first equation with the 8s minus the second equation with the 8s. And here we get 64 plus 24 plus 1. And here we get square root of 0. Well, this is 85. Minus 0 is just 85. Now we're going to multiply g and h of 0. Again, it's much easier to do the substitution first and then multiply. So g of 0 times h of 0. 8 minus 0 is square root of 8. We're going to multiply that times 2 times 0 plus 1, which is just 1, or 2 over 1, which gives us 2 square root of 8, but that can be finished. 8 can be broken down into 4 times 2. Extract the 4, so you get 4 square root of 2. H of negative 1. This time we're just dealing with the one equation alone. So we got the 2 over negative 1 plus 1, 0, undefined. Okay, write the domain in interval notation for these phrases, not just those. Remember, this is a graph where it goes on both sides, up and down. Okay, this is a graph where it's just a line with y-intercept of 4. This is a parabola shifted 3 places to the left. Okay, so if we're going to take r minus t, we take the r equation and we subtract the entire t equation. So we got that minus in the middle here. So we need to distribute that negative. When we distribute that negative, then we end up with x squared minus x minus 1. What is our domain of that? Well, that's just a parabola. And parabolas have negative infinity to positive infinity. Okay, this time we're dividing r by t. There's our 2 equations. Substitute it in. We've got a disclaimer that x cannot be 0. So we've got an exclusion, so we have a union. So we go from negative x, or negative infinity, to negative 4 not included, union with negative 4 not included, to positive infinity. Now we're going to multiply s and t. Here's s, here's t. We can distribute that. 2 times x is 2x, 2 times 4 is 8. X times over 1 is x. X cannot be 0. So we've got an excluded value, so we're going to have a union. This is a line. A line is infinite unless it's infinity to infinity, unless it's a vertical line. So, but we've got this exclusion of 0, so we've got a union for our answer. Negative infinity to 0, union with 0 to infinity. One more problem in this set. We've got m of x equals x plus 3, n of x equals x squared minus 9, p of x equals that. Find n minus m. The order matters. So n is x squared minus 9 minus x minus 3, okay, because I'm subtracting those, gives me this when you simplify it, which factors to this. So I've got these shapes right here. This thing is a parabola. Okay, that's a parabola. So really, we wouldn't even need to solve this. Once we saw this as a parabola, we wouldn't really need to go through this work because we know it's going to be negative to positive infinity. Now, that's the end of how far we're going to go today, and it's also the end of Chapter 2. Section 2.8, what I've covered today, will be on your exam 3. Are there any questions, either about the test or about this 2.8? Oh, I see we lost somebody. All right. Well, in that case, we'll see you tomorrow at 11:30.